Good evening and welcome to my laboratory. I'm going to see if I can pull this demonstration off. This is the circuit that I'm going to be looking at here. This is a variation of the laser saber crossover circuit. It's called that because of this crossover thing. And I call it the GhostLight circuit because I'm mostly interested in examining its very low voltage behavior with this ground connection and the touch bit up there. Okay, so also what I want to demonstrate is a very interesting failure mode of this transistor here when a 2N2222 is used and is damaged by inadvertently switching it to the Joule thief mode with 12 volts on the reservoir capacitor. Okay, so the additions that I've made to the circuit are I've put this double pole, double throw, or single pole, double throw center off switch here so that the circuit can be operated in GhostLight mode or in normal Joule thief mode. When the switch is switched to the center off position, it doesn't make any contact with the base of the transistor. When it's switched down to the Joule thief mode, it switches a 220K resistor from base to collector just to get this transistor oscillating. Excuse me. Okay, so that's one addition. The next addition is that I've put another 220K resistor with single pole, single throw switch to switch this resistor across the diode. The diode is necessary to get the GhostLight mode to work, but I also wanted to see if it would work as a normal low voltage Joule thief. With no resistor and no diode in here, it becomes the Gang of Thieves power supply that I showed earlier powering yet another Joule thief. But with this resistor, this allows me to bypass the diode and check to see what effect the diode is actually having by replacing it with a resistor. This capacitor here, this 1 microfarad 50 volt polyfilm capacitor, is because of the strange apparent battery recharging effect that you can demonstrate with the capacitor here. And I don't actually have a switch on the circuit, I just have a loop where I can touch and untouch the capacitor into the circuit, but it would be a good idea if you built it to put a switch there. Okay, so you've got several combinations of things going on here. You could have them both closed or one open, one closed, and you get different effects also in conjunction with operating down here. But I have to caution you, don't, if you have 12 volts on the capacitor, don't try to operate it in Joule thief mode because you can blow out the LED and this transistor. And that's the interesting thing. There's a failure mode of this transistor that occurred 3 times now. I've got 3 transistors that are failed in the same way, and I hope to show you what that failure mode is. And I failed them by having 12 volts on the capacitor and switching, having the resistor in, this switch closed here, and switching to Joule thief mode. And it pops the LED frequently, and it also and then with no load on it, it'll blow the transistor. So for the sequence of events is first the LED blows and then the transistor blows, I think. But at any rate, what I hope to do is show you what happens when you have this blown transistor here. For extreme low voltage and low current, I found that the MPSA 18 is a better transistor to use than the 2N2222. But the MPSA 18 is also more delicate and it's easy to blow out too. Okay, so that's the circuit. 4 minutes, wow. Okay, now here's the actual apparatus here, and I hope you can see everything that you need to see. This is the voltage on the capacitor bank. this is the current in the system right now. It's on the 20 milliamp range, so right now it's showing 8.56 milliamps. We're operating on the single battery from the power supply, keeping the capacitor charged to this 1.06 volts. We're in the Joule thief mode with the mode switch, and we're in the diode mode with the bypass switch. Okay, and there's the LED right there. Okay, see that going? All right, so normal Joule thief. This is a good 2N2222 transistor. It's fresh. All right, so if I go to off, you can see that the light fades and the voltage goes down. With the 2 battery mode, these are pretty dead batteries. I have about 1.9 volts on the battery. The Joule thief light is glowing more brightly, and I have a whole lot of milliamps of current. Okay. If I switch to the resistor mode, it doesn't really make much difference to the light, but if I switch over here, if I'm in the diode mode and I switch to Joule thief, I get the Joule thief light. Center off position, the light goes off. Ground loop or GhostLight position, the light goes off and the current drain goes down. Now, oh yeah, this is the ground lead to the external earth ground. Now I'm in the full-on GhostLight mode. You can see it flickering a little bit, and when I touch, I get the GhostLight, right? And that has to be with the diode selected up here. If I select the resistor, watch, boing. Even though it's in the GhostLight mode, now we're back to sort of a Joule thief operating mode, and the touch doesn't make any difference anymore. But I've got pretty high current, right? So to be in GhostLight mode, you need to be with the diode. All right. There it is. Again, GhostLight mode. Okay. So oh yeah, I forgot. You can turn the battery off when you're in the GhostLight mode. The battery's not needed as long as there's charge on the capacitor. And the current, you can see how the current goes way down. So there we're showing 46 microamps of current, and when I hit the button or touch, it goes up to almost a milliamp in this situation. Okay, so that's all with a normal 2N2222 transistor. You got a Joule thief mode, working pretty good on 1.6 volts with the diode in place. Nothing happens when it's in ground or GhostLight mode unless you have the resistor turned on. All right. So the switches definitely make a difference here. Okay. Now what I'm going to do is first, let's see, we'll discharge the capacitor by going to Joule thief mode and just let it run down like that. So now we get some voltage off the capacitor. Now I'll select diode and GL mode, and I'll put the other transistor in here. Okay. So I'll pull out the known good 2N2222 transistor and sub in, where is it? This one with the X on it. This is one of the failed ones. Okay, so I put that in there. Sorry about the light. I can just barely see this. Alright, so there's the bad 2N2222 transistor in there. Alright, so now if I have it center off over here, diode here, and I put some voltage on the capacitor, then if I turn the voltage off, the voltage drops immediately, and it didn't do that before. Alright, so put it on the voltage on, Joule thief on, light comes on bright. Now the switches don't make any difference. You see that? The light stays at constant on, the current is constant. Doesn't make any difference which way the switches are as long as you're getting power to the system. And it works pretty good as a Joule thief, but I don't know what's going on. I think that it's the 2N3055 that's acting as the Joule thief now. But okay, let's see. Watch this. If I turn the switch to off over here, and then turn that switch to off. Now when I turn it back on, see, it didn't start, right? Even if I go to the 2 battery position, it didn't start. But now, if I start it by going to here, now, once again, the switches don't make any difference once it's started. Okay. Is that not strange or what? Alright, so now let's go back to take this out and put the good 2N22 back in. Okay, and now we go to put 2 volts on there, diode mode, GL, we should be in GhostLight mode, and sure enough we are. And in Joule thief mode, good Joule thief. In that mode, switching the diode makes no difference. In the GhostLight mode, switching the diode does make a difference. In Joule thief mode, with 1 battery, got a difference. Solid difference. See how weird this is? See how the behavior is completely different with the good 2N22 than the one that was failed? It's crazy. Alright, that went long enough. I'm not going to demonstrate the really low current behavior with the MPSA 18 because that's very delicate. You can try that for yourself though. Alright, thank you for watching.